Alright, so today we're going to be taking a look at this soldering kit, and more specifically the soldering iron inside the kit. Let's go ahead and open this up. I'll show you what you get. This thing costs normally I think $23.99, but when I bought it there was a little option for apply a $3 off coupon, so this ended up being about $21 with Prime shipping as well. So it seems like a pretty good deal. You have what is supposedly a temperature controlled soldering iron. We will test that out here later in the video. Comes with 5 tips. We get a little wire stripper type thing. We get some red and black wire. Not real sure how long these are, but it doesn't really matter that much. We get a bit of solder, probably lead free. One of these solder sucker type things, which seems to have pretty good suction. We get a little stand, sponge, little flip up thing, a couple pairs of tweezers, and that's about it. Well, we get the instructions. So let's just have a look at the claims that this instruction sheet has. So looking at the front of this, it just kind of shows the features, I guess. So we have the guard wire in, which I assume they're talking about the strain relief on that, the handle tube of the soldering iron, the warming key, the power switch, the cooling key, the liquid crystal display screen, anti-skidding jacket, high temperature pullover, soldering bit joint point, and the soldering bit, which seems like it should be down here more. Alright, so looking at the inside of this, you can buy these in 2 versions. You can buy these in a 60-watt version or a 90-watt version, and I'll see if I can find the link. Well, I'll find the link for this for sure, this whole kit, and then I'll also try to find just the soldering iron. I also should point out, the reason why I bought the entire kit is because the entire kit has the Prime shipping option, and the soldering iron alone does not. I believe it ships straight from China, so it would have taken a little bit longer to get there, and I wanted this thing as soon as I could get it. So anyway, get the directions. We'll go over that later and how to change the tips and everything. I want to know the features of this thing. So we have the LCD digitally displayed soldering iron with adjustable constant temperature in a small shape. Unique soldering bit with joined body can be easily replaced. Yeah, that's definitely not a unique design. I'll show you that in a second. Only needs 0.5 seconds for the temperature to rise again, which is applicable for lead-free soldering. Okay. Only needs 8 seconds to warm up to the target temperature. It's made of wear-resistant, corrosion-resistant, and anti-static materials that feature a high temperature resistance. We have unique thermal insulation design for an excellent comfort level of the handle diameter. Okay. Temperature memory function, you don't need to adjust it each time it starts up. Okay. Voltage 220 or 110, depends on where you buy it from, presumably. Microcomputer temperature calibration function, temperature precision of plus or minus 2 degrees. Triangle grounding power lines and anti-static handles can conform to international standards. And then there's just some warnings, and the back of this is just blank. So, now before I get too far into this video, I do want to apologize for the 3D printer running in the background. I'm going to try to get rid of as much of that noise as I can, but no guarantees if it's going to be perfect. Alrighty, so let's get the interesting part out of here, and that would be the soldering iron. So I have been using this a little bit, as you can probably tell. So let's just go ahead and compare this iron to the one for the Hakko FX-888D, or the non-D version of the Hakko. Pretty sure those are the same irons. So there they are. Very, very similar. Overall, the Hakko one is a little bit shorter in total, but the tip to grip distance is actually slightly better on the cheap iron. It's probably not enough of a difference to where you'd really notice it, but you can see the grip is back just a little bit further on the Hakko one than it is on the cheap iron here. Now I do want to point something out on the cord of this unit. You'll notice it is a non-polarized 2-prong plug. Now if you go look at the Amazon listings, what you're going to find is that the pictures of this iron, the 60-watt version, have this plug on them, but the pictures in the 90-watt iron actually do have a 3-prong grounded plug pictured with them. I'm not sure if they really come with one of those, but it's pictured, so maybe you actually can get a grounded version of this iron if you wanted to, but unfortunately this one is not grounded. Now the unique tip changing design is one of these where you unscrew the little collar, this comes off, tip comes out, you slide a new tip on, you slide this back over, and you screw it in. Remarkably similar to the tip changing design of a Hakko FX-888D. Now what I do want to point out in here that there is a difference between this iron and most of the Hakkos and Hakko knockoffs here, is you notice that there is a piece of metal in this that kind of surrounds the heater up to where the tip goes on. So the tip slides on, it hits this, and then when you tighten down this metal piece over it, you're squeezing the tip up against this little flange here on this metal piece. So when you tighten this down, it's not actually putting any pressure on the heating element itself to tighten it down, it's putting pressure on that piece of metal on the inside. Now this one on the other hand, you just have this big heating element, and if you look down inside there, there's really no support for it. Now the next thing, since I got this taken apart already, next thing I'm going to point out is the replacement tips that come with it. Let's grab one of these out of here. We'll go ahead and put on one of these replacement tips and slide this on. And oh wait, it doesn't fit right. So the replacement tips that they give you in this kit just flat out slide in and out of the hole there. So that's pretty useless. And this is the tip that came on the iron. And if you look at them, there's a very clear distinction between the diameter of the two, which you can probably see there. This one is way thinner, and this one's quite a bit thicker than that one, so the replacement tips do not work very well. Oddly enough, I did get this tip to go into the iron once. I don't know how, must have just been a lot of luck, but I did get that one to work in the iron once. The rest of these are pretty much just useless. So I'll go ahead and put the little conical tip that it comes with back in here. And also, while we are on the subject of tips, it's the same changing mechanism as the Hakko iron, and they are the same tips as the Hakko iron. So these are like the, I think they're T18 series tips or the 900M series tips or something like that. So what that means is you can buy bags of just knockoff Hakko tips here. You can see the 900M there. And these are about 10 bucks for the 10 tips that are in the bag. And originally when I got my Hakko iron, I picked up a couple bags of these, so the other bags here now. And I used these for quite some time, and it wasn't until I started using the real Hakko tips I started realizing how bad these were. And just to describe the difference between the knockoff tips and the real Hakko ones, basically the Hakko tips are way better at transferring heat from the element to your workpiece than these are. These last a long time, I'll give them that. The the platings on the tips seem to be fine. Like, I haven't worn out any of them yet, surprisingly. Maybe I've worn out spots on a few of them, but I haven't completely worn out one of the tips. No, I haven't completely worn out a Hakko tip yet either, so I'm quite surprised at how long they last. The stand that the kit comes with is fairly decent. You got the little sponge on it, which you soak with water, of course. And it actually holds onto the iron reasonably well, especially compared to some of the stands that I've seen. But anyway, also a note on the cord here. It's decently flexible. Of course, this is a mains cord, so it's not going to be the really nice silicone that the Hakko has on it, which of course can just bend in whatever direction you want it to. But we'll also note that the cord on this is not temperature resistant, and if you touch the iron to it, it will melt the rubber on the cord. Now, one thing I do want to mention about this iron is it seems to be an updated digitally controlled version of the irons that have just a little temperature control knob on them. Now, the irons that just have that little temperature control knob are not really temperature controlled irons. All they are is like a triac light dimmer circuit built into a soldering iron. So it ends up being a wattage controlled iron instead of a temperature controlled iron. Now, apparently those work fairly well for what they are. Theoretically, this one is digitally temperature controlled. So I've got a couple of tools here to check this thing out, and we'll see if it's actually temperature controlled or not, or how well it's temperature controlled. First off, we've got a kilowatt meter. This will allow us to see if we're actually pulling 60 watts, and we'll also be able to see if it's using a dimmer circuit quite easily off of this device. And of course we have something that will actually directly measure the temperature of the tip. This is not a real Hakko device. This is a knockoff. These things cost like 20 bucks or something, but in reality what you have here is just a K-type thermocouple. There's not really too much to this thing. It's just not like NIST certified or anything, so that'll give us at least a decent idea as to how accurate the temperature is on this. We'll go ahead and plug in this iron. This is a completely non-polarized plug, and at standby, of course, it's pulling no watts, no volt amps, at least nothing that this can measure, so we'll leave that on watts. I don't know if you're gonna see it, but, and we'll turn the unit on, see what we get. We'll set it for 350 degrees C, because that's probably around where I would normally want to solder at. We're pulling 58, 56, 54. I think it started out when I first turned it on, it was pulling about 100 watts, and now it's dropping as the resistance of the element comes up. 45 watts. You can see the LCD in here is still blinking, which indicates that it's still warming up. And it looks like we must have reached temperature, because now, or it's slowing down at least, because it's turning off, it looks like. Only 19, 20 watts, 15 watts, 20, 28. So yeah, it looks like it's started to at least attempt to regulate the temperature at 350 degrees, because we're bouncing. Doesn't look like this thing can quite update fast enough to keep up with it actually, because this is bouncing all over the place, but I'm seeing it go down to like 8.4 and then up to 27. So it looks like it is pulsing the element on and off right now. Let's go ahead and grab the thermometer here. So it says 22 degrees C in the room. That doesn't seem completely unreasonable. We'll go ahead and put the tip on the temperature sensor there. Spiked up 368, 376. Mind you, we're set at 350. Mind you that this soldering iron claimed to regulate its temperature within plus or minus 2 degrees, and I do believe that this thermometer has got to be at least accurate to plus or minus 20 degrees C. And right now we're reading 394. And this is still set at 350. Now, one thing I will also note for anybody wondering, this thing does have a way to calibrate it. If you just tap the center button, it goes into a calibration mode, and I already have this thing set to a negative 50 degrees C calibration, and that's as low as it'll go. So it's calibrated as good as it's gonna get calibrated, unfortunately. Now, the next question is, if I set this down at say 290, I do use lead-free solder, so I usually solder around 350 degrees, or on the Hakko I'm usually set at about 675 to 700, so that's maybe 300 to 400 Celsius, something like that. It is definitely attempting to regulate the temperature, because you can see it turning itself on and off. I was kind of hoping that the update rate on this would be a little bit quicker, but it's doing something to regulate the temperature at least. Also, it probably won't tell us much if we go into like power factor or anything. Amperage. Yeah, it's not gonna tell us a whole lot. I mean, it's really just a resistor, so like your power factor is probably not gonna be, or maybe it's not gonna be that great. Okay. All right, now that it's set down at 290 for a little while, let's put it back on here and see what we got. So I set the temperature down by 60 degrees, which means it should be about 60 degrees lower in relative terms. And yeah, it looks like it did drop it by about 60 degrees, roughly. Now that actually brings up the question, maybe when I calibrated this, I didn't do it right. Let's just see what happens if we set the calibration value to 0 degrees C. Because maybe I was thinking about that backwards. And when I set that calibration value, what I wanted it to do was subtract 50 degrees off the temperature. What it may have done was thought that, or the way that it may be set up is that the temperature is read 50 degrees low, so you put negative 50 degrees in, and it raises the temperature by 50 degrees. So we'll set it to 0 degrees and we'll see what the temperature ends up being. All right, it's been sitting for a little while with that new calibration in it. Let's see what it reads. Yeah, so we're now up to 388, 390, 394. So yeah, putting the temperature calibration back to 0 degrees looks like it's just bumped our temperature back up by about 50 degrees. So it indeed needs to be turned down as far as it can be. Now another thing I will note is the manual says that this goes from 50 degrees up to 480, though the actual minimum temperature seems to be about 180, and I'll actually let it sit at 180 for a while and we'll measure the temp and see what we really end up with. 180 should not be enough temperature to melt the solder, mind you. Of course, this still has some residual heat in it, I'm sure. Also note right now with it set at 180, we are drawing 0 watts. So it must still be in kind of a cool down phase, even though it shows that it's at 180 degrees. All right, so we're set at 180. It's been sitting for a little while. Let's put this on here. See what we end up with. 215, 226. Which is about the melting point of the solder, I think, somewhere around 220. So 227 looks like, 226, 223. It's still dropping a little bit, so I'll give it some more time, I guess. All right, it's been sitting a little while longer. Let's go ahead and test again. I can already see that the solder's still melted, so we're definitely not below 180. It's definitely having a hard time melting the solder that's on there, so it's definitely colder. Yeah, 216, 217, still creeping up. I'll let the measurement device settle in here. 221, which means 223, 222. It's just gonna bounce around a little bit probably because it's attempting to regulate its temperature. And I can see the wattage bouncing between 0 and like 40 or so, which is probably just the meter having a hard time because it's not updating fast enough. So it's definitely attempting to regulate the temperature at some value. Unfortunately, it's still off by quite a ways. So we're 222 and we're set for 180. So that means we're off by about 35 degrees. And as I already showed, I have the temperature set already at -50 for the calibration. So I cannot set that any further, unfortunately. It just will not allow it. I will note that the LCD screen on this, it doesn't have a great viewing angle on it, though. I mean, it doesn't matter that much. It has almost no viewing angle if you turn it this way. If you turn it this way, it goes a little bit further. But I keep having to get that like dead center so that the camera can read it there. It's a little bit easier to read in real life than it is on camera, but I am kind of curious to see what we get up to if we just max the temperature out on this. Presumably, if it is temperature controlled, it will be about 35 degrees over 480. And let's see what the wattage does as this climbs up. Around 40. Which isn't particularly impressive, only about 30 watts going into it right now. Anyway, I'll let this heat up to 480, we'll see how long it takes to get there. Looks like we're only taking about 25 watts right now. We do not have a perfect power factor. We got about 0.76 on the power factor, which is interesting. You see our wattage is relatively stable at around 23, which is nowhere near 60. And it is taking us time to heat up to 480. We'll also mention that the grip here is getting kind of warm already, even though we haven't been testing this for an awful long amount of time. Currently we are still heating up to 480. It has not gotten there yet, according to the blinking LCD. I don't know if you can see that. Tip temp's currently 462. It's quite hot. 480 degrees C, by the way, is about 896 Fahrenheit, so 480 C and the 899 Fahrenheit that the Hakko max out at are roughly the same, so there's actually 480 right there. The iron is still heating. I'm curious to see if we end up 35 degrees over 480 in the end here. So right now we are locked at 480 degrees C according to the iron. We are still warming up though as the temperature goes from the element out to the tip. So we'll see if we end up at 35 degrees over 480. If the iron was set at 180 and we ended up at 225, that's 45 degrees over. Apparently I can't do math. Okay. Currently at 504. I think I just melted the thermocouple element. Okay, so apparently we can't actually measure temperatures that high. It's definitely hot. You can see the sort of Oh yeah, you can see how much flux smoke is coming off of that. And you can see that the tip is turning colors. Not the very tip, but the sort of cone-shaped piece that leads into the tip is turning a nice yellow color from the heat. All right, so one odd thing that I have noticed about this iron is sometimes when you turn it on, it does not heat up all the way, or really at all. So I'm gonna set this right now to 305 because in theory 45 degrees less than 350 is 305, so this should end up around 350, which is roughly where I'd want to solder at. And we'll see if this actually heats up. Should. You can kind of see how fast it melts the solder there. We're already melting solder, which is pretty impressive actually. It's not bad at all. So it is heating up just fine this time. What I found in the past is sometimes you go to turn it on and it doesn't get past probably like 100 degrees Celsius or so. Maybe a little bit hotter than that, but nowhere near hot enough to get solder to melt. And the way to fix it seems to just be to unplug it and plug it back in. So I don't know what the deal with that is, but anyhow, we are at supposedly 305 degrees. I got a new thermocouple on this thing. 346, 353, 355. Yeah, so 305 ends up around 350 degrees. Just out of curiosity, let's see what happens. Right now we're reading 355, we're set at 305. If I set it at 350, will it actually go down by 5 degrees? I was gonna say it might continue to go up because the tip might not be completely heat soaked at this point. So right now we're 354. Well, I'm impressed. I set it to go down by 5 degrees and it's gone down by roughly 5 degrees. This might be partially because I'm moving the tip around. Yeah, so it's gone down by about 5 degrees by setting the temperature down by about 5 degrees. So unfortunately the tip temp is still 50 degrees hotter than the set temp. All right, so this is somewhat cooled off. I'll go ahead and see if I can't take it apart and show you what you find on the inside of this thing. So if we take that off, first off, wow, that tip changed color. You can tell that we got it up to quite hot, actually. That's a nice purple color. But this part will also unscrew here. I think it'll unscrew easier if I kind of pull back the grip. So that'll unscrew. And then you can actually just unplug this. Like so. And this is the still quite warm heating element. And you'll notice something. There's only 2 pins on this thing. So how exactly do you measure the temperature on this? You notice it's also marked as 110 volts on it, but that doesn't really matter. So how on earth are they reading the temperature? Of course, if you've ever taken a Hakko one apart, which we can do that as well. So in the Hakko here, if you take this handle apart, you've got a total of 4 wires going up into the heating element. So 2 of those wires are for powering the heating element and the other 2 are for detecting the temperature of the element. So the question is, how are they getting away with 2 wires and still getting a relatively precise temperature control out of this iron? Now, notice I said precise, not accurate. There's a big difference there. Accuracy would imply that the temperature set on this LCD screen is the same as the temperature of the tip, and it is definitely not. But it does seem to be precise enough to where if you take the temperature and you set it down by 5 degrees, the temperature actually does drop by 5 degrees according to the thermometer, so that's interesting. And also, once you get the pins lined up, this does just slide right back in there. So if you can buy replacement elements for these, definitely isn't hard to change them. Now what I'm thinking what they do with this is, obviously there's 2 wires are where the power goes in, but on a 120 volt element like this, what's going to happen, or at least the way that they design most of them, they can probably design these however they want to, but on a normal non-temperature controlled soldering iron, if you have an element like that, what's going to happen is as it gets hotter and hotter and hotter, its resistance will increase. So instead of using a separate thermistor like what the Hakko does, what I'm thinking that they might be doing here is just measuring the resistance of the heating element itself, which would be kind of an interesting way to do that. So what you'd have to do is just turn off the power going into it, measure the resistance across the element real quick, and then turn the power back on, which does probably mean that you're going to have a limited amount of power that can go to the element because you have to shut it off periodically in order to measure the temperature. So for our next test, I've got a couple of pieces of 10 gauge wire here, and I'm not going to try to solder the wire together, but I'm just going to attempt to tin the end of the wire here. So I'm going to use the blue piece of wire for this iron, and I'm going to tin the other one with the Hakko. So from the bag of cheap tips here, I'm going to pull out the one that I think is the biggest chisel that's in here, which is this guy. And I want to say that this is probably like a 3.2 millimeter chisel tip or something like that. And I'm going to set this at 320 degrees, which if it's 50 degrees off, what we're going to end up with is roughly 370 degrees Celsius, which is about 700 Fahrenheit, which I believe that the Hakko should be able to do this at 700 Fahrenheit without much of an issue. And we will verify that our two irons are set at roughly the same temperature with this guy. So we're sitting around 360 according to this. 363, it is actually getting kind of close to where we want it set at. Bump it up by another 5 degrees, we get it to 325, and we'll just get this thing to read. So basically we're just going to try to get this thing to read about 370 degrees Celsius. 364. I think it's close enough. Let's see what happens if we try to tin this wire. Let's see what we end up with here. We just touch this on here. Get quite a bit of solder on the tip of this iron already. And yeah, no problem. Measure our temperature real quick, just out of curiosity, see what we get. See if there's like a horrible amount of overshoot on this or something, or if it's just going to be lower now because we of course just used it. Looks like it's just going to be lower because we used it. That's kind of to be expected. Of course, we're set at 370. It is kind of taking a little while to get back up there. That might be affected the tip though. So, honestly, that did really well. Of course, it is just a single 10 gauge wire, but that didn't have any problems with it, and this whole wire is warm now. So, let's go ahead and switch over to the Hakko just to see what it looks like. All right, so bringing in the Hakko here, I do have a genuine Hakko tip on it, so this definitely has a very unfair competitive advantage compared to the other iron. Currently have it set at 700 Fahrenheit. Looks like we're reading 367 C or so, so pretty close to what the other iron is at. This one's just a hair hotter maybe. Looks like it is actually going to get right to 370 degrees Celsius. And this did come up to temperature quite a bit faster, just as a FYI. So the Hakko is probably about 5 degrees C hotter, but that's going to be close enough. I mean, we're comparing soldering irons here. These weren't meant to be perfectly accurate, I'm sure. But anyhow, we'll get a little bit of solder on the tip. As mentioned, this is a genuine tip. This should perform quite a lot better. And there we go, that's tinned just fine. Of course, the Hakko has this really horrible alarm clock setting interface on it. If you've ever used one, you know what I'm talking about. But honestly, the temperature setting on this, which is just plus or minus 5 degrees up and down like that, works quite a bit better than the Hakko system, so I will give this iron that. Of course, also with the real Hakko, I just set the temperature to what I wanted and it went there with no problems. So there's also that. Which performed better in that test, the cheap iron here or the Hakko? Well, honestly, The Hakko did seem to heat this joint up a little bit quicker, and it seemed like the solder was flowing into it just a little bit easier. Though, honestly, there wasn't that much of a difference at the same temperature, which I was kind of surprised at, considering the fact that, I was using a real Hakko tip on the iron here versus our cheap knockoff Hakko tip here. But those seem to perform pretty similarly. Alright, so I'm just going to see if I can straight up melt these two 10 gauge wires together using that cheap iron. So supposedly we're up to temperature. I'm not going to check it again. We are going to just touch the back of these and maybe add some solder to the top and see if it can handle this. Still set at the same temperature, which it's set for 330 degrees. Of course, it seems like we're ending up right around 370. Taking a while to heat this up. Feels like it wants to melt it. It's trying. Honestly, at this point, we might be more limited by the tip than the actual iron. See if I can just remelt one and then melt it into the other. That might work. According to our kilowatt meter, we're still bouncing between like 0 and 25 watts, so it's really not dumping that much power into the tip. Which you can kind of probably tell because the solder on the actual tip is not really wanting to melt. You can see there. Now that our tip's kind of not as hot as it was before, we're not melting things too well. Especially with two wires. Wires are definitely very hot, so it's putting heat into them, but yeah, those two don't seem to want to melt together with this iron. Very well could be due to the tip though, not the iron itself, I will say that. Alrighty, so we have the Hakko now. Hakko is currently set at a lower temperature. We're set closer to probably about 360 degrees C. Which, of course, as I mentioned before, we were running this at a slightly higher temperature than the other irons, so this might be a bit more of a fair shot, I don't know. But we're going to try to melt these two wires together with the Hakko and see what we end up with. I may actually have to bump the temperature back up because it just hit that and froze. Nope, we're starting to do it. And there it is. We have the two wires successfully melted together. Mind you, that was with the Hakko, and that was at a lower temperature than this iron was at. So that gives you a bit of an idea that the Hakko does perform a bit better than this. Of course, as I mentioned, that could all be down to the tips of the iron versus the actual performance of the iron itself. Of course, if you're going to buy an iron like this, you're probably going to end up buying cheaper tips. That's why I'm testing it with the cheap tips. But I could switch over the real Hakko tip onto this just to see if it performs any better. Alright, so this time, same tip that was just on the Hakko. This is a genuine one. You can probably see the logo, stuff on that. That's going to go onto our cheap iron. Fits on just fine. Screw this little collar thing back over it. And turn it on, we'll see what we get. This will actually now be a little bit hotter than the Hakko was. Let's go ahead and give it a shot, see what happens. And that's why these Hakko tips are a lot better than the cheap knockoffs. Alright, so between this cheap iron and the Hakko FX-888D, they do perform both pretty well, though I would say that the Hakko performs a bit better than this iron does. But also, if you put a genuine Hakko tip into this thing, it performs quite nicely, really. I do think, just looking at the kilowatt meter, that this thing has more power than this does once it's heated up. This seems to drop off to about 50 watts. This still seems to be able to put out roughly 60, 65, though how much of a difference that's going to make, I don't really know. First off, this is what I got. I did get the price a little bit wrong. It's $25.99 with a $3 off coupon, so that makes it around $23 or $22.99 to buy this kit. And the coupon, as you can see, is still there. And it's Prime eligible, as I mentioned. So this just goes over what's in the kit and stuff like that. So I also will note that you can change this pattern name thing. If you go over to the A pattern, you get one of these irons that does not have the digital display, and instead is just the old knob like I was talking about earlier, where it's essentially just a light dimmer circuit built into a soldering iron. So that's an adjustable wattage soldering iron as opposed to an adjustable temperature soldering iron. So this iron does appear to be temperature controlled, and it's temperature controlled fairly precisely from what I can see, though the accuracy leaves something to be desired, because if you have the calibration value of this thing set at 0, the temperature of the tip will be something like 100 degrees C off compared to what you have it set on the LCD. And even with the calibration tweaked as far as I can tweak it, where the temperature is still about 50 degrees hotter than the set temperature, though it does seem to regulate temperature fairly nicely. Now, of course, on something like the Hakko, your temperature regulation is probably going to be a lot better than something like this, and also the accuracy of the temperature just out of the box calibration on the Hakko is going to be way better than than even the best accuracy that I can get out of this thing. And if you do want to buy the iron by itself, you can get the 90 watt version, which, as I mentioned before, the pictures for the 90 watt version do show a 3-prong power connector. So this one might actually be ESD safe if that ground pin is connected to the metal up here, and a lot of people would probably prefer that over one that's only 2-prong, because if something does somehow go wrong in that heating element, like the ceramic chips off or something, and it shorts to the metal casing, it's shorting out to the ground and it'll pop a circuit breaker, versus just having a potentially live wire connected to the casing of that, which wouldn't be the greatest thing, though. You know, just make sure that that heating element doesn't get chipped, and it should be just fine. Same temperature control and everything on the 90 watt, and if I switch over, 90 watt on its own costs $24.99, and the 90 watt one does have Prime shipping. The 60 watt one does not have Prime shipping for whatever reason, though it is still free shipping. Presumably coming straight from China, because it is estimated delivery from the 13th to January 7th. Very, very wide range. And right now it is the 21st of November. And like I said, the pictures of this one do show the 2-prong cord, so presumably these pictures of the individual units are accurate. Now, there is another type of soldering iron that I haven't really talked about yet, and that would be these sort of 936, Hakko 936 knockoff irons. So one of the more recognizable ones is the Yihua 936, which you can buy off of Newegg, which is really just buying it from Hobby King, as you can see, sold and shipped by Hobby King down here. For some reason, when you look up Yihua 936, the Newegg link comes up as the first thing. But anyway, these go for around $20 as well, similar price to this, though it is worth noting that usually you're going to have to pay for shipping if you buy one of these 936 knockoffs. So you're $8.71 in shipping and about $20 for the actual iron. So you're looking at roughly $30 for this versus actually paying $20 for this iron. Though honestly, this is probably still more accurate than the temperature on this, even if it is that sort of cheap knockoff of a soldering iron. Now, as much as I'd love to compare both this iron and this iron to a TS100, I do not have a TS100. I did consider purchasing a TS100, and I decided against that because it really is kind of an expensive iron, and I don't need anything quite that fancy to do basic work that I wanted to do with this thing. Now really the TS100 just isn't that cheap of a soldering iron. It gets into the price range of the FX-888D once you start including the power supply and whatnot. So even the soldering iron alone is still something like $60 plus, then you got to pick up a couple of tips, and the tips are like $15 a piece for that thing. They're not all that cheap. It is a good iron from what I hear, though the performance of a TS100 is going to vary wildly depending on what power supply you hook up to it. This is pretty much going to be consistent across all your 110 volt outlets, because roughly, you know, those are all about the same. Same thing with the Hakko, of course. Now, is this thing capable of being a Hakko killer or a TS100 killer? Now, the TS100 is kind of in an interesting position because there's a lot of guys that fly like quadcopters and whatnot that like the TS100 because they can just plug the TS100 into one of their battery packs and use it as a field iron. So for the people that want a you know, TS100, for that reason, are going to still have to have a TS100 because this isn't really capable of running off of a battery pack unless of course you have one that can output 110 volts, which there are power banks that will output 110 volts. They're kind of expensive and kind of rare, and of course they're not the same ones that you use for your quadcopter that you just happen to have with you when you're out flying them. Now in terms of just bench soldering irons, I don't see why you couldn't use this as a normal bench soldering iron. It is miles and miles ahead of something like this where you just plug it straight into the wall and it just kind of works. This is a 60 watt completely non-temperature controlled iron. This is actually the iron that I started soldering with. This is what I learned with. So I definitely started with the bottom. This was 10 bucks at a local hobby shop. Came with 2 tips, and I think it even came with a little bit of solder and, you know, the little cheap stand. Now, unfortunately, I don't really have the tools to directly compare the performance of this iron versus this iron. Though I will say, if you slap a real Hakko tip into this, it performs pretty well. It's pretty close, at least, to this iron. Just looking at the numbers that the kilowatt meter gives, this is about 10 watts less power-wise than this one. Not real sure how much of a difference that's really gonna make, but if you're just buying this iron to solder like circuit boards and things like that, I think you'd be quite happy with it. You do just have to be mindful that the temperature reading is gonna be way out of whack. Now maybe I just got a bad unit, mine could just be way off compared to some of the other ones, I don't know. If the manufacturer of this, whoever it is, I don't think this has any kind of real branding on it. I basically just keep referring to this thing as a cheap soldering iron because it really doesn't have a brand to it. The Amazon listing for the soldering iron itself is listed as KK Moon, but I think KK Moon is basically just a big distributor of random stuff that comes from China. If I'm not, yeah, like you can buy a DIY calculator and some other stuff. Looks like RC airplanes. Yeah, it looks like you can just buy all kinds of stuff from this KK Moon place. So I don't think KK Moon's the real like brand of the soldering iron. I think it's more like just the distributor that's selling these things on Amazon. Now, if the company that is making this soldering iron can make it so that the displayed temperature on this is, say, within 20 degrees of the actual temp temperature, this would be a really good iron, I think. I don't see too many problems with it. We'll see how reliable it is in the long run, I guess, but I do intend on continuing to use this thing. But if the temperature display was more accurate, I think that this would make a great iron. And really, I mean, it makes a great iron as it is. You just have to be mindful that the temperature is going to be about 50 degrees hotter on the tip than what the temperature says, even with that calibration turned all the way down by 50 degrees. And of course, with the calibration set at 0 degrees, it's almost, the temp ends up being like 100 degrees hotter than the set temp. Now, I would say if you're in the market for a temperature controlled soldering iron, this is worth a look. You do have to be mindful that the temperature on the tip is going to be hotter than the temperature on the display, and that's basically the only catch with this thing, because really it seems to perform pretty well. It seems to be able to hold the temperature fairly well, and overall I'm pretty happy with this thing, and I am going to continue to use it. So we'll see how the long-term reliability on this ends up being, but for now I would probably recommend this if you were looking for probably just about the most budget temperature controlled soldering iron that you can get. So anyway, that's it for now, guys. Bye.